These are the notes for pre-calculus for 9.1. It's due 4/27, so it's due Monday. It's that substitution elimination. It's just like 3-2B and C. It's just like that worksheet. So I'm just going to go over some things. Now, on the computer, you have a choice. If it tells you to use elimination or substitution or whatever, you have a choice because the computer can't tell how you solve it. So I don't care. So I'm going to give you suggestions on how I would do it. So if you see something like this, x plus y equals -3 and y equals x minus 6, you're going to be told to solve by graphing. We'll solve it first and then graph it, and I'll tell you the best way to graph these two lines on there because you can't just use slope and y-intercept like we're used to. So I'm going to show you x and y intercepts. But if you see something like this where you've got a variable by itself, which this is something I talked about when I went over the worksheet, go ahead and substitute that in where the y is, right there. So you'd have x plus x minus 6 equals -3. That'd be 2x minus 6 equals -3. So you'd add 6 to both sides. 2x equals 3, divide by 2, so x is 3/2. Very hard to see that on a graph. That's why graphing method is not the best method, but it does ask. I think there's 4 of them that ask you to graph it. So you find the solution and then graph them. Actually, you may not even have to put the solution on in the graphing. Well, there's 2 where you don't have to, and there's 2 where you have to. So anyway, this just gives you practice on doing this. So if x is 3/2, I've got to find y. You've got to make sure you have both of them. So I'm going to use y equals x minus 6. So that would be 3/2 minus 6. Finding a common denominator, 3/2 minus 12/2 gives me -9/2. So my answer would be 3/2, comma -9/2. You're going to have to put them in parentheses in an ordered pair in the computer and on the test that you're going to have over 9.1. So make sure that you do that. Make sure that you get them in the ordered pair correctly, that kind of stuff. Now let me show you what I think is going to be the best way for you to graph these, okay? And it's called the intercept method. And all you have to do is find your x and y intercepts. And you're going to have to graph both lines. So if we look at x plus y equals -3. For your x-intercept, you simply let x equal your constant. So your x-intercept is -3, 0. So you're going to graph -3, 0. Your y-intercept, you let y equal the constant. So your y-intercept would be 0, -3. So this would be left 3 up none. This would be here, and then 0, -3 would be here. So that's how that would graph, something like that, okay? But on your computer, what I'm trying to get at is I'm giving you 2 points to graph, and 2 points make a line. So if you'll graph the x-intercept and the y-intercept, you've got 2 points that make a line for you, okay? Then on the other one, y equals x minus 6, again, if we let y equal the constant, which is -6, so my y-intercept is 0, -6, or you should be able to look at this. It's in slope-intercept form, and your y-intercept is -6. Now for x, it's a little more tricky. For x, we'd have to do 0 equals x minus 6, and then solve for x. This is something we did in Algebra 1, a tad bit in Algebra 2. So this would be 6 equals x. So your x-intercept would be 6, 0. So y-intercept is here, x-intercept is here, then, and it says your intersection is at +3/2. This is a +3/2, and then down -9/2. So it would look something like that, okay? But my point is the computer should let you graph 2 points, like your x-intercept and your y-intercept, or your x-intercept, your y-intercept. So do them that way, okay? I'll show you another couple like that, so you can get that x-intercept, y-intercept thing down. Let's see, so 4x minus 3y equals -2, and -8x plus 6y equals 4. Now you're going to be told to use graphing to solve this. You don't have to. Just go ahead and solve it, but you're going to have to graph it. So I'm going to show you how to graph it here in just a minute. Let's see. Okay, so I would use like elimination. I would multiply the top by 2. So I would get 8x minus 6y equals -4. Then I'm going to rewrite -x plus 6y equals 4. everything cancels, 0 equals 0, that means there's infinitely many solutions, okay? That means there's just one line. There's just one line here. So really to graph this, you only have to graph one line. So let's look at the negative 8x plus 6y equals 4. So if I want the x-intercept, I let negative 8x equal 4, divide by negative 8, so x equals negative 1/2, so it'd be negative 1/2 comma 0. You should be able to graph a fraction like that. You should be able to do that. And then 6y equals 4 for my y-intercept. This is my y-intercept. Divide by 6, so y is 2 over 3. So 0 comma 2 over 3. That's your x-intercept and your y-intercept. That's 2 points that you should be able to graph. If the computer doesn't let you graph the x and y-intercept, choose values for x and find y. Like choose positive 1 for x and solve for y. Like I'd do negative 8 times 1 plus 6y equals 4. And then that's negative 8 plus 6y equals 4. Add 8 to both sides. So 6y equals 12. Divide by 6. So y is 2. So when x is 1, because I said x was 1, y is 2. So there's a point you can graph. So you can choose values for, I would choose easy values for x, like 1, 2, whole numbers like that. But you should be able to graph these x and y intercepts, okay? But either way, but they won't let you use slope and y-intercept. That's my point. You can't use slope and y-intercept like we're used to. Then again, they'll have something like negative 2x minus 2y equals 16 and 2x minus y equals negative 4. This is already set up for elimination. Elimination, you've got opposites. So if I add vertically, these cancel. I'm left with negative 3y equals, what is that, 12? So divide by negative 3. So y is negative 4. Then if y is negative 4, I need to find x, so I plug back in. So 2x minus negative 4 equals negative 4. I use the bottom equation. I use 2x minus y equals negative 4. So then 2x plus 4 equals negative 4. Because that minus negative 4 equals a positive 4. Subtract 4 from both sides, so 2x equals negative 8. Divide by 2, so x is negative 4. So negative 4 comma negative 4. That's your solution. And then again, if you're asked to graph the two lines, and the only reason I showed you, on that last one, I just showed you how to graph one of them because there's just one line. So you'd only graph one line. Because if there's infinitely many, that means they lie on the same line, okay? This intersection is at negative 4 comma negative 4. And again, sometimes when you're graphing, the first 4 are graphing. The first 2, I think, won't ask you for the ordered pair, so just get them graphed. The second 2 will ask you for the ordered pair, and you have to graph them. So there's an ordered pair. And then to graph them, like if we were going to graph negative 2x minus 2y equals 16 using intercepts, you'd set negative 2x equals to 16, divide by negative 2. So x is negative 8, so it's negative 8 comma 0. And then same thing with your y. So y equals negative 8, so it'd be 0 comma negative 8. So those are the two, that's your x-intercept. This is on the x-axis at negative 8. This is on the y-axis at negative 8. Then for the second one, 2x minus y equals negative 4. You set 2x equals negative 4, divide by 2. So x is negative 2, so negative 2 comma 0. And then negative y equals negative 4, so that means positive y equals 4, so 0 comma 4. So there's your x-intercept and your y-intercept. Those are 2 points that you can graph because you have to graph both lines and they're going to intersect. And they should intersect at negative 4 comma negative 4. Okay? Let's do one more graphing one. Y equals 2x and negative 4x plus y equals negative 1. This one is set up for substitution because y equals 2x, so I'm going to take that 2x right there, put it right there where the, sorry, woo, yeah, that was a mess up. Going to put it right there where the y is. So negative 4x plus 2x equals negative 1. So that's negative 2x equals negative 1. Divide by negative 2, and x is 1/2. So if x is 1/2, plug it back in. We know y is 2x, That's one of the original equations. So 2 times 1/2. So y is 1. So 1/2 comma 1. So there's the point of intersection. That's where they intersect. And then now to graph them, on the y equals 2x, you'd have y equals 0 because that's your constant. And then you'd have 0 equals 2x, so divide by 2. So that'd be x equals 0. So your x and y intercept are both 0, 0. So that's not going to work because they're both the same. So then choose x equaling 1. So if x equals 1, then y is 2 because it'd be 2 times 1. So you'd have another point of 1, 2 for that y equals 2x. Then negative 4x plus y equals negative 1. So negative 4x equals negative 1. So divide by negative 4. So x is 1/4. So your x-intercept would be 1/4, 0. And then y equals negative 1. So you'd have a y-intercept of 0, negative 1. So that's how you'd graph this line. And then you'd graph this line with a 0, 0 because the x and y intercepts are the same. So then we have to find another one. How do we find another one? Just plug 1 in for x and find your y. And that's your other ordered pair. That's your other point that you can graph. And it only takes 2 points to make a line, so that should work. Then the rest of them are all just using substitution or elimination. Sometimes you have to identify whether they are consistent, inconsistent, consistent dependent, inconsistent independent, that kind of stuff. So, and again, it doesn't matter how it asks you to solve it. Some of you may even want to use Kramer's rule. If you remember Kramer's rule, that's fine. Just make sure you show your work when you turn it in. I'm going to do elimination, and I'm going to multiply this top one by 5 because I already have opposite signs on my y's. So that would be 5x minus 5y equals negative 5, and 2x plus 5y equals negative 16. So then the 5y's cancel. I get 7x equals negative 21. Divide by 7. So x is negative 3. If x is negative 3, I need y. So I'm going to plug it back into that top one, that x minus y equals negative 1. So negative 3x minus y equals negative 1. Add 3 to both sides. Negative y equals 2. So positive y equals negative 2 because you just changed the signs. So negative 3, negative 2. In parentheses, this is consistent when they start asking. This is consistent and independent. Okay? Consistent and independent because you had a solution. Consistent and independent because you had a solution. Let's see. 9x minus 7y equals negative 44. And then 9x plus 68 equals y. Okay, so on this, we've got some rearranging to do. Or you could use substitution. Y equals 9x plus 68. You could do it that way. You could absolutely do substitution. What I would do, just because I'm not much of a fan of substitution, I would switch the y and the 68, making sure I change both signs. Now that's the issue here. You have to be careful. If you've got to move them, you've got to change the signs. So that's just an option there. Or again, you can use substitution because y equals 9x plus 68. You could take this, put it right there by the 7 and go from there. Or if you want to use Kramer's rule, you've got to change it this way if you're going to use Kramer's rule. So using substitution or Kramer's rule, you've got to have it set up where your x's and y's and constants are lined up. And if you move anything, make sure you change the sign. I'm rewriting the top one. I am changing the signs in the bottom one because I'm multiplying by a negative 1. My x's cancel. I get negative 6y equals, now my brain hasn't been working today, so I am going to use a calculator on this, on the negative 44 and 68, which gives me 24. Divide by negative 6, so y is negative 4. Then if y is negative 4, I'm going to plug it back in so I can find x, because I need x. Doesn't matter where. You know what? I'm going to put it right here. 9x plus 68 equals negative 4. And then I'm going to subtract 68. That's going to give me 9x equals negative 72. Divide by 9. So x is negative 8. So, sorry, glare. Negative 8 comma negative 4. This is consistent and independent. consistent and independent, and they're spelled ENTs, not ANTs. When they ask, sometimes they'll ask you to classify it, sometimes they won't. Okay? And you'll have some substitution ones. If they're set up for substitution, use substitution. Let me show you one where you've got 2x minus y equals 3 and 4y equals 8x minus 12. Again, lots of options, but just FYI, this down here, you can divide everything by 4. So y equals 2x minus 3. Then you could take that and put it right up there where the y is. So I'd have 2x minus 3 equals 3. So then that'd be 2x minus 3 equals 3. Well, 2x minus 2x cancels. Actually, that'd be a plus 3 because I'd distribute the negative. So then 3 equals 3. That's always true. So this is infinitely many again. So then one of your choices is going to have an x. It's going to say infinitely many. And then it's going to have an x and a comma and a line. And you're going to put 2x minus 3 because it's this line. It's on that line, y equals 2x minus 3. So that's what you put in that space. X and then 2x minus 3. So when there's infinitely many, sometimes it'll just have you put infinitely many, and then sometimes it'll put infinitely many and then have the parentheses x with a space after it, and in the space, the equation of the line is what goes there because it's on that line. They both are that line right there, okay? And this is called consistent and dependent because they're the same line. Consistent and dependent. Okay, so that's what that looks like. 6x minus 4y equals 1. 3x minus 2y equals 3. So I'm going to use elimination. I am going to multiply the bottom one by a negative 2. I'm going to rewrite the top one. 6x minus 4y equals 1. Negative 6x plus 4y equals negative 6. These cancel. 0 equals negative 5. Not true. No solution. And this is called inconsistent. So when there's no solution, this is called inconsistent and independent because they're actually two different lines. So it's inconsistent and independent when you're asked to classify them. Okay, there's that one. You're going to see possibly some with decimals in them. So the first thing I would do is get rid of the decimals. 3x minus 2y equals negative 9. 2x minus 3y equals negative 11. Whoops. And then go from there. Let's see. I'm going to multiply the top by a negative 3 and the bottom by a 2. So that gives me negative 9x minus 6y equals 27. And then 4x, actually that would be plus 6y, I didn't change the sign. Because it'd be negative 3 times 3x is negative 9x. Negative 3 times negative 2y is positive 6y. And negative 3 times negative 9 is 27. And then 4x minus 6y equals negative 22. Again, this is a review. This is something we did in Algebra 1 and Algebra 2 both. And some of you may remember Kramer's rule. Use Kramer's rule. So negative 5x equals 5 because the y's cancel, which is what we want. Divide by negative 5 and x is negative 1. And then if x is negative 1, we need y. So I'm going to plug into one of these, not an original one, because I just don't want to deal with the decimals. You can deal with the decimals, but I don't want to. So I'm going to use 3x minus 2y equals negative 9. So that'd be 3 times negative 1 minus 2y equals negative 9. So negative 3 minus 2y equals negative 9. Add 3 to both sides. So negative 2y equals negative 6. Divide by negative 2, so y is 3. So negative 1 comma 3, that's consistent and independent if you're asked. That's consistent and independent if you're asked. Then know that parallel lines are inconsistent, no solution. Those are parallel lines. Inconsistent, no solution, parallel lines. And then remember, you can have consistent and dependent. That's when it's the same line and there's infinitely many solutions, okay? And then the consistent independent, is one solution where the lines meet at one point. Okay, they meet at one point. That's the consistent independent, the one solution. And then this can be inconsistent and independent. We've seen that too. That when there's no solution, it can be inconsistent and independent because they're two separate lines. Okay, then you're going to have some word problems. One of the word problems, you've got a total of 2,679,000 people live in metropolitan areas of Las Vegas, Nevada, and Sacramento, California. Sacramento has 279,000 more residents than Las Vegas. So Sacramento has 279,000 more residents than Las Vegas. So Sacramento is 279 plus L. And then together, Las Vegas, Nevada, and Sacramento, California. So Las Vegas and Sacramento equals 2679. So you're looking for two unknowns. You want the population of each metropolitan area. So I'm using L and S. So S is Sacramento, L is Las Vegas. Again, Sacramento was 279 more than Las Vegas, and then together Las Vegas and Sacramento have 2,679. This is set up for substitution, so I'm going to take that 279, put it right there. So L plus 279 plus L equals 2679. So then 2L plus 279 equals 2679. Subtract 279. So 2L equals, again, I'm going to not rely on my brain today because I hadn't been working all that great. 2,400 divide by 2. So Las Vegas has 1,200. Okay, and you have to make sure you put it in for the right one. And then Sacramento is 1,200 plus 279, so 1,479. That's for Sacramento. So make sure you put them in the right place in the computer. Okay? Then you can have some with values on it. So let's see. We've got Fran's Flicks gave her a free DVD rental or a 12-serving box of macaroni popcorn to new members. If it costs the store $1 for each rental, so $1 for each rental plus $2 for popcorn, and it was $112 total for the incentive. So it cost them $1 per rental, $2 per popcorn. They spent $112 total, and they got 62 members out of it. So they had to give rentals plus popcorn to 62 different people, okay? So this is the way it sets up. I'm going to use elimination. I'm going to multiply this bottom one by -1. So I'm going to rewrite the top one. 1R plus 2P equals 112. Then -R minus P equals -62. So my R's cancel. I get P equals 50. So it was 50 boxes of popcorn. So this is your popcorn. And then a total is 62. R plus P equals 62. So I know R plus 50 equals 62. So subtract 50. So R is 12. So 12 rentals. Make sure again that you put them in the right slots. And a couple more like that. You've got a coffee counter. There's $9 per pound for Kenya French roast and $8 per pound for Sumatra. We want to know how much of each type should be made. So we want to make 20-pound blend and we want it to be $8.70. Now we want this 20 pounds to have that value of $8.70. Okay, so it's $9 for the Kenya French roast. It's $8 for the Sumatra coffee. We want to know how much of each type should be used to make 20 pounds total, but we want the value on that 20 pounds to be $8.70. So we have to fix this right here in this top one. So I've got value, and then the value on the 20 needs to be $8.70. Okay, so then first thing I'm going to do is multiply 20 times $8.70, which is $174. Okay, then I'm going to multiply the bottom one by, -8. So I'm going to rewrite the top one. 9K plus 8S equals 174. And then -8K minus 8S equals -160. So then I get K equals 14. So you're going to need 14 pounds of the Kenya roast. That's 14 pounds. Make sure you get it in the right order. And then if there's 20 pounds total, you just do 20 minus 14 and you get 6. So 6 pounds of the Sumatran one. Yeah. Okie dokie. Okay, then we have a boat in the river problem. It goes 72 kilometers downstream in 3 hours, and it travels 72 kilometers upstream in 4 hours. Find the speed of the boat and the speed of the stream. So we have to remember that distance is rate times time. Okay, now the distance is 72. This is downstream, and it's also 72 upstream. Okay, so this distance is the rate times the time. Well, if I'm going downstream, then that means the current is with me. So the rate of the boat plus the rate of the water, and it only takes 3 hours. That's my time, and that's what it tells me in the problem. A riverboat travels 72 kilometers downstream in 3 hours. So if you're going downstream, your rate, the rate of the boat, is plus the water. The water's going to push you. If you're going upstream, it's going to take 4 hours. You're still going to 72, but if you're going upstream, the water's against you. So it's actually going to take the rate of the boat and slow you down. Okay? So here are the two equations right there that you've got. So my suggestion here, these numbers right here are usually divisible into this one. So I would go ahead and get rid of it first. I'd get rid of both of those first. Then you've got R plus W equals whatever 72 divided by 3 is, 24. And then you've got R minus W, 72 divided by 4, 18. Now look, elimination, perfect elimination now. You can't eliminate here. You've got to get rid of the 3 and the 4 first, then it's perfect elimination, okay? Then you've got 2R equals whatever 24 plus 18 is, 42. Divide by 2, so R is 21. So this is the rate of the boat. This is the rate of the boat. Okay? Now, we want the speed of the stream as well. So we want W as well. So you can take this, plug it in one of these. 21 plus W equals 24. So subtract 21. So that's 3. And these are kilometers per hour. And this is the water. This is the current. This is the stream. Okay? So that's boat in the river problem. That's how you do. This is downstream is a plus, upstream is a minus. And that's how you set them up. Distance is rate times time. Okay, then you've got one last word problem. The supply and demand for a product. Oh, they give you these. Y equals 400 plus 40x, and y equals 10,400 minus 60x. So this is a demand curve and a supply curve. You want the equilibrium point. If you want the equilibrium point, that's when demand equals supply. That is your equilibrium point. So you just set them equal to each other. 400 plus 40x equals 10,400 minus 60x. So you add 60x to both sides, and you get 400 plus 100x equals 10,400. Subtract 400. You get 100x equals 10,000. 10,000. Divide by 100. So x is 100. So that's part of the equilibrium point. Now you need to find the other one. So you just take the x and you either plug it into the first one or the second one. It doesn't matter. I'm going to plug it into the first one. So 400 plus 40 times 100. So that'd be 400 plus 4,000, which would be 4,400. So your equilibrium point is 100, 4,400. That's the perfect point. Like really, that's not only equilibrium point, that's the optimum point. That's where demand equals supply, and that's like perfect in economics. So that's your equilibrium point. And then one last type you're going to see. You've got ax plus by equals 1. That's your equation. And you're given that one solution is 2 comma negative 1, and another solution is negative 5 comma negative 2. And you want to find a and b. Okay, so what you need to remember, these are x's and y's, both of them. That's an x, that's a y, that's an x, that's a y. So set up 2 equations, because you're looking for 2 unknowns. So set up 2 equations and 2 unknowns. So we're going to take this x, that's 2, and put it with a. We're going to take that y that's negative 1 and put it with b, and it equals 1, not negative 1, right? It's a positive 1, yeah. Okay. Then the negative 5 and negative 2. So negative 5a minus 2b equals 1 as well, okay? Then elimination or substitution or Kramer's rule, whichever one you feel more comfortable with. I'm going to multiply the top by a negative 2. That'll give me negative 4a plus 2b equals negative 2. So then my b's cancel. I get negative 9a equals negative 1, because 1 minus 2 is negative 1. Divide by negative 9. So a is 1 over 9. That's a. Now we've got to find b, which I've shown that. So now we want to find b. So let's see. I'll put it in that top one, that 2a plus negative b equals 1. So 2 times 1/9 plus negative b equals 1. So it'd be 2 over 9 minus b equals 1. Subtract 2 over 9. So I have negative b. 1 minus 2 over 9. Well, 1 is 9 over 9. So 9 over 9 minus 2 over 9 is 7 over 9. Because it's 9 over 9 minus. This is minus. 9 over 9 minus. 1 minus 2 over 9. That's 7 over 9. Negative b equals 7 over 9, so positive b equals negative 7 over 9. So a was 1 over 9, and b was negative 7 over 9. That is less than 9.1. That should be a review. You just probably needed to get the dust off your brains about things. It's not due until Monday the 27th, and then you've got that worksheet 3-2B and C. That's not due until Monday as well. So neither assignment is due until Monday. Yeah, so this is 9.1.